Hi everyone. In this video we'll talk about a new value called the margin of error. The margin of error is similar to another value we've already talked about called the standard error. The standard error and the margin of error actually have the same purpose. Their purpose is to get an idea of how accurate a random sample is likely to be. Since the standard error and the margin of error both have that same purpose, they're both called measures of accuracy. Even though the standard error and the margin of error have the same purpose, they're calculated differently, and they're also interpreted differently. I think the difference between the standard error and the margin of error will make sense by the time we get to the end of this video. In this video, we'll go through an example of calculating the margin of error. We'll go through a step-by-step example, but before we do that, we'll go over the definition of the margin of error, and we'll also go through a few diagrams just so you get an idea of what the margin of error means. So let's start with the definition. The margin of error is the distance from the population parameter being estimated to the lower and upper boundaries of an area in which the sample statistic has a certain probability of falling. And I know this definition probably sounds wordy and it's probably not quite clear yet, but I think it'll make sense once we look over a few diagrams of the concept. Let's start with this diagram right here. In this diagram, we're imagining that this point right here is a certain population parameter or population statistic that we want to estimate. It could be the mean of a certain population, or it could be the percentage of something in a certain population. This point right here is just some population statistic that we want to estimate. To estimate this unknown population statistic, we're going to take a random sample from the population, we're going to collect data from the sample, and then we're going to calculate a sample statistic to estimate the population parameter. When we calculate our sample statistic to estimate the population parameter, our sample statistic is going to fall somewhere along this number line. It probably won't be exactly equal to the population parameter because hardly any sample statistic is perfectly accurate. But it'll fall somewhere along this number line, along this range of possibilities. It's going to be more likely to fall somewhere around the population parameter, and it's going to be less likely to fall way down here or way out here because random samples are usually fairly accurate and they're extreme less often. They can turn out to be extreme, but it doesn't happen very often. Now, let's look at this red area right here around the population parameter that we're estimating. And let's try to imagine what we think the probability is that the sample statistic will fall in this red area. Let's just try to take a guess. Well, this red area looks pretty narrow, and the sample statistic would have to fall pretty close to the population parameter and be pretty accurate in order to be in this area. So the probability of the sample statistic falling in this red area probably isn't too high. Maybe we could guess that it's 0.60 or a 60% chance. If it's true that there's a 0.60 probability that our sample statistic will fall in this red area, then the distance from the population parameter to each of these two boundaries would be called the 60% margin of error. The distance from the population parameter to the lower boundary and the distance from the population parameter to the upper boundary would both be called the 60% margin of error. And so this is the 60% margin of error, and this is also the 60% margin of error, and these two are the same distance. In other words, the 60% margin of error would be half of this total red area right here. Earlier in the video, I told you that the definition of the margin of error is the distance from the population parameter to the lower boundary and the upper boundary of an area in which the sample statistic has a certain probability of falling. And that's what we see in this diagram right here. We have an area in which the sample statistic has a 0.60 probability of falling, and the distance from the population parameter to the lower and upper boundaries of the area is a margin of error. The reason why this is called the 60% margin of error is because there's a 0.60 probability of the sample statistic falling in the area. If this probability was different, then this percentage would also change, because this number and this number are always the same. It's just one's a decimal and one's a percentage. So if there was a 0.50 probability of the sample statistic falling in this area, then this would be the 50% margin of error. If there was a 0.80 probability of the sample statistic falling in this area, then this would be the 80% margin of error. Like I said, these two numbers always match up with each other. Let's now look at another diagram. In this diagram, let's move the two boundaries out further away from the population parameter, so we have a wider red area. And now let's think about what the probability would be of the sample statistic falling in this red area. Well, since this red area is really wide and it covers almost all of the possible numbers that the sample statistic could equal, there's probably a pretty high chance that the sample statistic would fall somewhere in this red area. Let's say that maybe there's a 0.95 probability of the sample statistic falling in this red area. If that's true, then these two distances would be called the 95% margin of error, because, like I said, this number and this number match up with each other. So I hope these two diagrams helped you start to get an idea of what the margin of error represents or what it stands for. Let's now look at a couple other diagrams so we get an idea of how the margin of error is connected with the idea of a sampling distribution, which is something we've been talking about lately. So if we have a population and we take a random sample from the population and we calculate a sample statistic, there's more than one possible sample that could be selected from the population. For example, if we're taking a random sample of 50 people, there's many possible samples of 50 that could be selected. There's many possible combinations of 50 that could be selected. And the actual sample will just be one of those possible samples. The possible samples that could be selected have a distribution called the sampling distribution. And if the sample is large enough, then the sampling distribution has a normal distribution like this. The possible samples have a normal distribution. If the sample statistic is a mean or a sample mean, then the rule is that the sampling distribution is normal, always normal, if the population is normal, and the sampling distribution is at least roughly normal, always if the sample is 30 or larger. That's the central limit theorem that we talked about in another video. So if the population is normal, or our sample is at least 30, and we're calculating a sample mean, then the sampling distribution is normal like this. Now let's look at this diagram and think about where, let's think about how far the 70% margin of error would go out this way in each direction. Well, at a certain point down here, and at a certain point up here, we're going to have the boundaries of the area that includes the middle 70% of the possible samples that could be selected. And there's a 0.70 probability of the sample statistic falling in that area.